In this video, we're going to explore rearranging buffer equilibrium calculations to solve for any of the missing info. So in this case, I have a mixture of 0.5 molar phenol. It's got a pKa of 10.0, and it's sodium salt, so the conjugate base. This mixture has a pH of 9.3. What I want to know is, what is the concentration of the conjugate base? So what do we know here? Well, I've got a weak acid and its conjugate base, so I'm going to have the acid breaking part. This is our standard by convention way of thinking about it. We think about the acid breaking part as our primary reaction. And so it's going to be the reagent. It's going to make the H plus and the conjugate base. This becomes Ka is equal to the H plus, the products, the conjugate base, all over the acid. Which pieces of info do we know? Well, we have a pH, so we do know the H plus concentration. It's going to be 10 to the negative 9.3. I want to solve the base concentration, so don't know that yet. That's what we're trying to get to. I was given the phenol concentration, so I do know that the phenol is 0.5 molar. Well, that Ka, I'm given the pKa, which I can use to solve the Ka. Remember that 10 to the negative pKa, just like 10 to the negative pH, will give us the actual value. So 10 to the negative 10. And if you run that, it's actually 10 to the minus 10. Conveniently, because it's right on 0, it ends up being the same. This is 1 times 10 to the minus 10. So we do know our Ka. We had to find it from our pKa, but we have that. So the only thing we're missing is the base concentration. Now I need to rearrange to get the base concentration on its own. So I'm going to multiply the acid up. I'm going to divide the H plus concentration down. All that is going to equal the concentration of our base. 0.5 times 10 to the minus 10 divided by 10 to the minus 9.3. The concentration of my base must be equal to 0.0997. So just about 0.1. This is roughly 0.1 molar base. Because we can rearrange this equilibrium expression, as long as we know 3 of the 4 components, we can always solve the 4th missing component. We might have to think about how to get some of these. In this case, we had to modify our pKa to find the Ka. We had to modify our pH to find the concentration of H+. But as long as we can obtain 3 of these 4, we can always rearrange to solve for the 4th. Do you want to know what the pH of a mixture is? Rearrange to solve for H+. Do you want to know what the Ka is? Know all the other parts, know the pH and the 2 concentrations, and just calculate it out. Do you want to know the concentration of the acid needs to be? Well, we'd have to rearrange. We'd need to know the Ka, the pH, and the base concentration. The acid would get multiplied up, the Ka would get divided down, and we could solve for the acid concentration. This relation can be reworked to solve for any of the 4 variables as long as we know the other 3. Just sometimes our sources of that info might be a little obtuse, and we have to make a few changes to obtain them.